So over here we have the threshold of human hearing, which is 0 decibels, and it's 1 times 10 to the negative 12 watts per meter squared. That's the intensity of sound. And then here at 120 decibels, we have an intensity of 1 watt per meter squared. And that's, just a power per area, basically. This equation right here is from the textbook, and it basically just says that the intensity is equal to the change in pressure, which the change in pressure, if you look at a wave, like if we plotted a sound wave, sound waves are longitudinal waves, but if we plot it with pressure versus time, or even distance, we would get a wave that looks like this. And so the difference in pressure is actually going to be our amplitude, which the question is ultimately asking about. So this delta P is going to be our amplitude. And then it's divided by 2 times rho. That symbol rho stands for the density of whatever the sound wave is traveling through, which we're going to assume is air. And the density of air is 1.225 kilograms per meters cubed. And that can also be gathered from the textbook, as well as times the speed, which is the speed of sound in air, which is 343 meters per second. Both of these are constants or things that are given to you in the textbook. And these two things are given to you in the problem. So now what we can do is we want to know what is the difference in pressure or amplitude, basically, between 0 decibels and 120 decibels. So the way I would do this is I would first solve for the amplitude. So let's rearrange this equation for that. So I'm going to multiply 2 times the density times the speed on both sides. That's going to cancel that out, but then I have to do it on this side as well. So I have I times 2 times the density times the speed is equal to the change in pressure of the amplitude squared. And then you have to, in order to get that by itself, you have to square root both sides. And so that's going to be the square of that whole thing. So to rewrite it neatly, the change in pressure or the amplitude is going to equal the square root of the intensity times 2 times the density times the speed. So what we're going to do is we're going to do this twice, once for 0 decibels and once for 120 decibels, but we have to plug in the intensities, not the decibels. So let's go ahead and do it. So for the 0 decibels, it'll be 1 times 10 to the negative 12, which is given to us in the problem, times 2 times 1.225, which is the density of air, times the speed of sound, 343, and that's the square root of all of that. So let's put that into the calculator. So the square root of 1 times 10 to the negative 12 times 2 times 1.225 times 343. And I get my first amplitude, which would be 2.9 basically times 10 to the negative 5. And then if I do this again, but this time plugging in just 1 for the power or for the intensity, because that's 120 decibels. Then I get 1 times 2 times 1.225 times 343, and the square root of that whole thing. Putting that into the calculator, I get 29, and this would just be in power units, which is, or pressure units, I'm sorry. But the difference between these, if I put this in scientific notation, it would be 2.9 times 10 to the 1. So the difference between those two is times 10 to the 6, because that's the order of magnitude difference that they're at. So because this is times 10 to the 1, this is times 10 to the negative 5. So if I were to divide them, 2.1 times 10 to the 1 divided by 2.9 times 10 to the negative 5, what you get is, if I put that in the calculator, sorry, just punching it in, you get 10, 1, 2, 3, 4, 5, which is, of course, 1 times 10 to the 6, which is what we were talking about.